Can we pass an argument to any function? See this simple C program. Here I am passing the two numbers to the function called add. So this is possible. Like this, can we pass an argument to the C program's main function? Yes, we can. Check this C program. We are passing the arguments to the main function using this argc and argv. As we are learning the Linux device driver in this series, is it possible to pass an argument to the Linux device driver? Yes, it is. That's what we are going to see in this video. Hello everybody, welcome back to Embetronics. This is SLR from Embetronics. Please make sure to press the like button if you like this video. Subscribe to us and press the bell icon if you want to get notified whenever we post the new technology video. Let's get started. Before we start, we must know about the permissions in Linux. These are the permissions that we are used commonly. SIW user, SIR user, SIX user, SIR group, SIW group, SIX group. Here, SI is common. W means write, R means read, X means execute, and USR means user, and GRP means group. So, this gives writes permission to the user. This queue gives read permission to the user, execute permission to the user, read permission to the group, write permission to the group, and execute permission to the group. Also, using the OR operator, we can set multiple permissions at a time. Okay, let's move to the original topic. First, we will see the APIs that are available. Module param. Module param macro is used to define the normal variable that we are going to pass to the driver. The first argument to this macro is name of the variable. Second is the type of the variable like integer, character, etc. The last argument is the permission like read, write, execute. Whenever you define the variable using this macro, it will create a sysfs entry under the sys module directory. See here, I am telling the value ATX variable is going to be used as an argument whose type is int and giving read-write permission to the user. It will create a sysfs entry like this: sys module, your module name, parameters, value ATX. So we can access this variable using this sysfs entry anytime. Module param array. Using the previous macro module param, we can assign the normal variables, but using this module param array macro, we can assign the array variables. It has 4 arguments: array name, type, number of elements, permission. Let's move to the another macro called module param cb. This macro is used to register the callback function. But what is the relation between module arguments and the callback function? Okay, I will tell you the example. When you write the variable or read the variable, it should notify the kernel. So that time the callback function will be called. See, the value ATX is created using the module param. So it will create this sysfs entry. When the device driver is running, we can change the value of this variable using that sysfs entry. I am writing 1 to that sysfs entry. Now, how does the driver comes to know about this change? If we have registered the variable using this module param cb, then that callback will be called. We can set 3 callbacks using this structure. One is for the write operation, another one is for the read operation, and one is for the free operation. If you are not clear, it's okay. You will understand in this demo section. In this program, I am defining 4 variables: integer, integer array, character pointer, and integer. The value ATX integer and name ATX character pointer are registered with the module param macro. ARR value ETX array is registered with the module param array. I am not assigning the callback function to these three variables. Callback is assigned to the CB value ETX integer. This is the callback function that I have created. Whenever we change the value of the CB value ETX using this sysfs entry, the kernel will call this callback where we are setting this value. If that returns OK, then I am printing the value. We need to register this callback function. I am setting this callback function to this set member of that structure. As I don't have the callback for the get, I am using the standard param_get_int function as the get function callback. I am using this macro param callback to register the variable and the callbacks. So, whenever we change this CB value ETX, our notify param should be called. When you change the other variables, no callback function should be called. In the init function, we are just printing all the variables, and in the exit function, we do nothing. We are using this makefile to build the source code. Let's see the demo. Build the device driver in both Ubuntu and Raspberry Pi. Load the module with the arguments. Okay, I have inserted the module already. Let's unload that. Run the same thing in Raspberry Pi as well. Check the D message. See, the callback function is called as we changed the CB value ETX to 20. Other variables also get updated without the callback function being called. See the Raspberry Pi. There is also the same output. We have passed these arguments to the driver. Now, I am going to change the variable value ETX to 20 using the sysfs entry. Check the D message. No callback function has been called. The same test is in Raspberry Pi with the same result. Now, let me change the CB value ETX variable to 30. See here, the callback function has been called and the CB value ETX is 30 now. Raspberry Pi also produces the same output. Now, unload the module using the sudo rm mode. That's all. I hope you understood. Please comment below if you have any doubts and subscribe to our channel. In our next video, we will see the major number and minor numbers. In the description, I have provided the link of the source code and the web version of this video. Thank you. Take care.